Newton's rings are observed normally in reflected light of wavelength 590 nanometer. The diameter of the 10th dark ring is 5 millimeter. Find the radius of curvature of the lens and the thickness of the film. So here the lambda is given. It is 590 into 10 raised to minus 9 meter. The diameter of the 10th dark ring D10 is given as 5 millimeter, that is 5 into 10 raised to minus 3 meter. Find the radius of curvature R and the thickness of the film T. So we have the equation for the diameter of the nth dark ring as d square n is equal to 4nr lambda. 4nr lambda, where n is the order, r is the radius of curvature, and lambda is the light source used. So using this equation we can find out first r. That is, here the d10 is given 5 into 10 raised to minus 3. Therefore this d square 10 is equal to 4 into n is 10. Here n is given as 10. 4 into 10 into r lambda. Lambda is also given. That is, the d square 10 means is 10 is 5 into 10 raised to minus 3. That is, d square 10 is 5 into 10 raised to minus 3. The whole square is equal to 4 into n 10 into r into this lambda will be 590 into 10 raised to minus 9. Here we can find out r, it's equal to, this square means 25 into 10 raised to minus 6 divided by 4 into 10 into 590 into 10 raised to minus 9. That is, this will give about 1.059 meter. This is the radius of curvature. Then using this r, we have to find out the thickness of the film. So we are again using the condition for dark band or destructive interference. Here the diameter of the dark band is given. The condition for dark band is, or the destructive interference is 2 mu t cos r is equal to n lambda. Here n is 10, n is given as 10, and t should be find out. The mu is, in the case of Newton's rings, we are using the air film. So mu for the air is 1. Mu for air is 1. And for normal incidence, r is equal to 0. In the case of Newton's ring, normal incidence we are considering. So the equation is mu 1 r 0. Then this equation becomes 2t is equal to n lambda, or n is 10, 10 into lambda is 590 into 10 raised to minus 9. Therefore the t becomes 10 into 590 into 10 raised to minus 9 the whole by 2. That is, this will give the value as, the value is about 3 into 10 raised to minus 6 meter. That is 2.95. We are approximating it as 3. 3 into 10 raised to minus 6 meter. Then the second question is, the Newton's rings are formed by reflection in the air film between a plain glass plate surface and a spherical surface of radius 1 meter. If the diameter of the third right ring is 1.81 millimeter and that of the 13th right ring is 5.01 millimeter, calculate the wavelength of light used. So here r is given as 1 meter, and also the radius of the third ring D3 1.81 into 10 raised to minus 3 meter, and the radius of and the diameter of the third ring and the diameter of the 13th ring D13 is equal to 5.01 into 10 raised to minus 3 meter. Calculate the wavelength of light used. Lambda should be find out. So we have the general equation for the n plus mth and nth ring. That is, the general equation is d square n plus m minus d square n is equal to 4mr lambda. This is the general equation. D square n plus m minus d square n is equal to 4mr lambda. D square n plus m means the diameter of the n plus mth ring. Dn is the diameter of the nth ring. It should be 4mr lambda. So here d square 13th minus d square 3 will gives 4 into this is the m will gives 13 minus 3. It is 10 into r lambda. This is the value. So here we can find out the lambda. That is, the d13 is 5.01, d square 13 square of this 5.01 into 10 raised to minus 3. d3 is 1.81 into 10 raised to minus 3. The square of d3 square is 1.81 into 10 raised to minus 3 the whole square. That is 5.01 into 10 raised to minus 3 the whole square minus 1.81 into 10 raised to minus 3 the whole square gives 4 into 10 into r is given as 1 meter, 1 into lambda. Therefore, the lambda should be 5.01 into 10 raised to minus 3 the whole square minus 1.81 into 10 raised to minus 3 the whole square, the whole divided by 4 into 10 into 1. So this will give the value of lambda as about 546 nanometer. 546 into 10 raised to minus 9 meter. The next problem is, in a Newton's rings experiment, the diameter of the fifth dark ring is 3.36 millimeter and the diameter of the 15th dark ring is 5.90 millimeter. Find the radius of curvature of planar convex lens if the wavelength of light used is 589 nanometer. That is, here the diameter of the fifth dark ring, that is d5, is given as 3.36 into 10 raised to minus 3 meter. Then 15th dark ring d15 is equal to 5.90 into 10 raised to minus 3 meter. Find the radius of curvature r if lambda is given, that is 589 into nanometer means 10 raised to minus 9 meter. So similar to the previous case equation, we can write d square 15 minus d square 5 is equal to 4 into this 15 minus 5, that is 10 into r lambda. R should be find out into lambda. d15 is 5.90 into 10 raised to minus 3. Then d square 15 should be the square of this term. And d5 is 3.36 into 10 raised to minus 3 meter. And the square of d5 means the square of this term. So we can write 5.90 into 10 raised to minus 3 the whole square minus 3.36 into 10 raised to minus 3 the whole square divides equal to 4 into 10 into r into this lambda should be 589 into 10 raised to minus 9. Therefore, the lambda is, for the r is r equal to this 5 this square term means it is something 34.81 minus 11.2896 into 10 raised to minus 6 the whole divided by 40 into 589 into 10 raised to minus 9. And this will give about 0.998 meter. This will give 0.998 meter.